Thank you for the kind introduction, and welcome to you and also maybe the people in the online stream. Yes, I'm from Fraunhofer IMWS, which stands for Microstructure of Materials and Systems, and I will present you a project that we are developing at the moment, the Electrolysis Research and Test Facility. At first, my institute is located in Härle, which is in the eastern part of Germany. The head of our institute is Professor Ralf B. Werkstoffen, and we have several locations in Germany, and one of them will be soon the Electrolysis Research and Test Facility in Leuna. We have about around 300 employees and an annual budget of around about 20 million euros. I myself, I'm acting head of the group Water Electrolysis inside the business unit Chemical Conversion Processes, which is divided into carbon circular technologies and the water electrolysis. As I mentioned, we're at the moment planning a research and test facility in Leuna. Why Leuna? That's a good question, because Leuna is here in the eastern part of Germany, located in the chemical triangle, as you can see here. The chemical triangle has a specialty. There's a 150 kilometer long hydrogen pipeline connecting the chemical sites. It is fed in Leuna by a steam reformer plant and then distributing the hydrogen. And the ELP will be located in Leuna, right next to the steam reformer plant. The chemical side is a huge plus because you have a utility supply system and some other advantages I will show you a little bit later. Here, the project is planned by two Fraunhofer-Institutes, my institute, the IMWS, and the CBP, which is already located in Leuna. We will have research infrastructure with lab space, technical center, and office space, as well as an outside area where we can test and evaluate large-scale electrolyzers up to 5 megawatts. Because the outside area has a grid connection with 5 megawatts, and we have space for 4 projects, which are hooked up via a utility supply system. And we are fully integrated into the chemical side. We will be open for all technologies, so it doesn't matter if the electrolyzer is an alkaline, high temperature, or PEM electrolyzer, we can handle it all. And we will be fully operational in 2020. Here you can see how the projects will be hooked up. There is this utility supply station where we have all the needed utilities, for example, nitrogen, or for high temperature electrolysis, the steam and deionized water, which is also in the chemical, available in the chemical side. And then the produced hydrogen will be fed into the hydrogen pipeline, so we don't get rid of the hydrogen, we reuse it. Some projects, they still vent the hydrogen, but it's way too expensive to do that. And other projects will be that we have the electrolyzer and some downstream processes. Our specialty is the testing and evaluating of electrolyzers, and then the CBP, they are more a chemical and process engineering institute, so they are focusing on downstream processes like methanol synthesis. And then that's a picture where you can see that might be a project. Here we have that space for 40-foot container, one 40-foot container, and we can have 3 of them here or 3 of them there. Every station has the utility supply system. That's the building where we have the technical center, lab space, and office space. And that's the pipeline supply system. Then our research topics from the institutes are design and failure diagnostics. So we're focusing on microstructure analysis, and really important part of that is the sample preparation. So we can not only evaluate the electrolyzer, but we are also in the process of engineering and material science, and of course modeling and simulations. Doesn't work at the moment. Oh, now it was faster, yeah. So one thing we focus on is the reliability and lifetime of, for example, MEAs. In our laboratory in Härle, we have this little test stand where we run tests on MEAs. And that will also be a focus on the electrolysis research and test facility. And then after running the small system, we can, the one cell, we can run the whole system and look what is happening to the whole system afterwards. And then after the test runs, we do the microstructure analysis and realize what other research has been needed. Then this project is funded, the ELP is funded by Fraunhofer, the state of Saxony-Anhalt, and EFRE. One project as an example, this is called Synlink. Here we are involved in the material development, so we look into heat exchangers and look why they are failing. And then the project is one CO2 capturing unit from the air. That will be coupled with a co-electrolysis system. We get this project to the ELP and run the whole system there. And another part of the project is the Methanol Synthesis, which is run by the CBP in Leuna. So that's the project status of the Synlink project. There are, sorry. Sorry. Okay. One? Yeah. We have further projects. We are also involved in the HYPOS here in the state of Saxony-Anhalt. For example, one project is ELP, that's cost reduction of alkaline electrolysis. REVAL is reversible anion exchange electrolysis, and some other projects. So if you're interested working together with us, you will find us at booth E51 together with HYPOS. Thank you.
Thank you very much, Dominik Härle. Are there any questions from the audience regarding the project facility in Leuna or anything else about the Fraunhofer-Institut?
Do you know if there's been any projects developed using hydrogen on wind farms?
Of course, there are projects looking at electrolyzers on wind farms. There's one project that is in the making at the moment where decentralized electrolyzer is might be hooked up to a wind farm directly without grid connection, and then the produced hydrogen, the plan is to feed it into a salt cavern. That's, if I have a backup for that question, sorry. That's another HYPOS project where, as you can see here, is Leuna, and here's a underground storage in Bad Lauchstädt. There are salt caverns, and the plan is to have a wind farm here, around 40 megawatts, and then produce hydrogen and feed it into the salt cavern. So that's one project we are also involved in, and other partners, Terawatt, for example. And there we have a huge H2 storage, underground storage in Saxony-Anhalt.
Thank you very much for the question. Further questions? Okay, if not for the moment, thank you very much again, Dominik, Härle, for your time and presentation. If you have further questions, it's booth E51 in this direction. Have a great week. Thank you very much.
Thank you.